In the operating room, a surgeon's hand holds perfectly steady while the lights stay constant and a ventilator breathes for a patient who cannot breathe on their own. Somewhere in the basement of that hospital, a transformer hums at a frequency that has not changed in over 130 years, 60 cycles per second, the same rhythm I calculated in 1888. Every intensive care unit, every subway car, every server farm keeping your digital world running depends on a decision made in 1893 when humanity chose between two competing visions of how electricity should travel across distance. One vision belonged to the most celebrated inventor of that age, Thomas Edison, whose system would have required a power station on nearly every city block in every major city. The other vision belonged to a penniless immigrant who had seen the complete solution appear before him like a waking dream while reciting German poetry in a Budapest park. Edison staked his reputation on proving my system was not merely inferior but deadly, and he was half right about the danger in untrained hands. What he got catastrophically wrong was everything else. What I understood about power transmission escaped even that remarkable mind, and understanding it transforms how you perceive every wire, every motor, every humming machine in the world you inhabit today. Thomas Edison opened Pearl Street Station in Lower Manhattan in 1882, and it stood as the first central power station in America designed to serve paying customers. His direct current dynamos fed electricity through copper cables to 85 buildings within a 1-mile radius, and approximately 400 lamps glowed with steady, reliable light. Newspapers declared a new age had arrived while investors lined up to fund expansion, because Edison had proven that electricity could be commercialized and sold like gas or water. Pearl Street Station also demonstrated something Edison refused to acknowledge, and that was the fundamental limitation that would doom his entire approach to electrification. That single station burned coal around the clock and employed a small army of operators, yet it could illuminate just 1 square mile of Manhattan. Electrifying all of New York City would have required hundreds of such stations, and electrifying America would have required tens of thousands scattered across the landscape. Direct current carries within it a physical law that cannot be negotiated or engineered around. When current flows through a wire, that wire resists, and resistance transforms electrical energy into heat that radiates uselessly into the air. Longer wires mean more energy bleeding away, and higher current means greater waste with every foot of copper. Delivering meaningful power over any distance requires pushing enormous current through the lines, and enormous current means enormous losses that make the whole enterprise economically absurd. The obvious solution would be to increase the voltage and push harder, but here is the cruel mathematics that imprisoned direct current technology in the 19th century. Power equals voltage multiplied by current, which means you can deliver a given amount of power using high voltage with low current, or low voltage with high current. Low current allows thin wires and minimal losses, while high current demands thick cables and produces tremendous waste. Direct current as it existed then offered no practical method to change voltage after generation, none whatsoever, and the electricity emerged from the dynamo at whatever voltage the dynamo produced, and stayed at that voltage until it reached the customer's lamp. Every direct current power station had to generate electricity at the exact voltage its customers required, approximately 110 volts for Edison's incandescent lamps. That low voltage meant the current had to run high, and high current meant the power could not travel far before turning into worthless heat. Edison understood all of this, because he was not a fool, and within his constraints, direct current worked elegantly for a single building, a single block, a single square mile of dense urban customers. His error was thinking too small and optimizing for the world as it was rather than the world as it would become. He built for wealthy city dwellers living near their power source, while I built for a world where power generated at a waterfall could illuminate homes hundreds of miles away. The problem consumed me for years before that afternoon in Budapest, not as an intellectual puzzle but with an intensity that physicians feared would kill me. Working at the Central Telegraph Office in Hungary as a young man, I pushed myself to the point of physical collapse trying to solve this riddle of distance and power. My senses became painfully acute in ways I could not control, and I could hear a watch ticking 3 rooms away while the vibration of a carriage passing in the street felt like an earthquake through my entire body. My doctors believed I would not survive that period of obsession. The solution to a great problem does not arrive through greater effort, and this is something about invention that most people never understand. The mind must make a leap that logic alone cannot provide, a sudden seeing that comes from somewhere outside conscious reasoning. Almost all my waking hours have been devoted to thought, but if work means a definite performance in a specified time according to a rigid rule, then I may be the worst of idlers who ever lived. My method differs completely from the method Edison employed throughout his career. An idea comes to me, and I start at once, building it up in my imagination, changing the construction, making improvements, and operating the device entirely in my mind until it works perfectly. Edison tested over 3,000 materials for his light bulb filament by examining each one empirically and recording the results. 0 materials did I test for my motor because the motor existed complete in my imagination before I touched metal or wound a single coil of wire. February of 1882 brought the answer, the same year Edison was celebrating Pearl Street, the same year he was confident he had solved electricity forever and would dominate the industry. My illness was fading, and I walked through the city park in Budapest with my friend Anthony Szigeti while the sun set in colors I can still see when I close my eyes. Poetry filled my mind as I recited Goethe's Faust, which I had memorized entire in German. The glow retreats. Done is the day of toil. It yonder hastes, new fields of life exploring. And that's when everything changed. As if a veil had been torn from some inner vision I did not know I possessed. The complete system appeared before me, generator, transmission lines, and motor, rotating in my mind with the solidity of metal and stone. I seized a stick and drew diagrams in the sand while Sigeti understood them perfectly, and I told him to see my motor here, to watch me reverse it with nothing but my will. Pygmalion, seeing his statue come to life, could not have been more deeply moved than I was in that moment. 1,000 secrets of nature, which I might have stumbled upon accidentally, I would have given for that one which I had wrested from her against all odds and at the peril of my existence. What I saw was the rotating magnetic field, and understanding what those 4 words mean requires understanding what Michael Faraday discovered half a century before my birth. Faraday demonstrated that magnetism and electricity are aspects of the same fundamental phenomenon rather than separate forces operating independently. Electric current flowing through a wire creates a magnetic field around that wire, and a magnetic field moving past a wire induces electric current within it. Every electrical engineer of my era knew these principles, but Faraday never imagined the application I conceived that evening in Budapest. Picture 4 electromagnets, arranged in a square surrounding an open central space, and now imagine feeding them with currents that reach their maximum strength at different moments. One after another, like waves passing along a shore, different magnets pull with different intensities in different directions at any instant, but because the currents cycle continuously in deliberate sequence, the combined magnetic force sweeps around the central space in continuous rotation. A magnetic field spins without any mechanical part moving at all, created purely by the timing of electrical waves. Place a simple metal cylinder in that rotating field with no wires connected to it, no brushes, no commutator, nothing but a chunk of conductive material, and something remarkable occurs that still amazes me to describe. The spinning magnetic field induces electrical currents within the cylinder, and those induced currents generate their own magnetic field that interacts with the original rotating field. The cylinder begins to chase the spinning magnetism and rotates along behind it, pulled by invisible forces that require no physical contact whatsoever. This is the polyphase induction motor, and it has no sparking brushes to wear out, no mechanical commutator to fail, no electrical connection to the spinning rotor. Physics alone drives it, elegant and reliable, and nearly indestructible physics that has powered civilization for over a century. Creating a rotating magnetic field requires currents that alternate, currents that rise and fall in reverse direction and follow the sinuous pattern of a wave. And this is the essential insight that changes everything about power transmission. Nature operates through ebb and tide, through wave motion at every scale of existence. Your heart beats in alternating contractions, while your neurons fire in rhythmic pulses, and sound travels as compression waves through air, while light itself is an electromagnetic wave crossing the void of space. Alternation is how nature moves energy, which meant that, in all branches of industry, alternating currents would have the sway. Alternating current offers something even more powerful than the induction motor, and that something is the transformer. A transformer does for electricity what international banking does for currency, because it converts energy for transport without creating any new energy, which would violate the laws of physics that govern the universe. The device itself approaches absurd simplicity. Just 2 coils of wire wrapped around the same iron core with no moving parts whatsoever inside the housing. Feed alternating current into the primary coil, and an alternating magnetic field forms within the iron, and that pulsing field induces alternating current in the secondary coil through pure magnetism with no electrical connection between the 2 windings. The voltage in the secondary coil depends on the ratio of wire turns between the 2 coils, and this relationship unlocks everything that direct current could never achieve. 10 times as many turns in the secondary produces 10 times higher voltage, and 1/10 as many turns produces 1/10 the voltage, while energy stays conserved throughout the process. When voltage rises, the current falls proportionally, and when voltage falls, the current rises to compensate. What this means for power transmission changed the world and the way humans live upon it. Generate electricity at a moderate voltage that's safe for workers and practical for generators, then step it up through a transformer to tens of thousands of volts or even hundreds of thousands for long-distance lines. Enormous voltages mean the current drops to a trickle, and a trickle of current loses almost nothing to resistance even across hundreds of miles of relatively thin wire. At the destination, another transformer steps the voltage back down to safe levels for homes and factories, and power flows from source to use with minimal waste along the way. The distance problem that imprisoned direct current simply evaporates when you understand how to work with alternating current and transformers together. The International Commission, evaluating proposals for the Niagara Falls Power Project in 1893, included skeptics who doubted the falls could provide electricity to Buffalo, 26 miles away through wilderness. My conviction was that the falls could power not merely Buffalo, but the entire eastern portion of the United States, and I had already presented my complete polyphase system to the American Institute of Electrical Engineers in New York on the 16th of May, 1888. George Westinghouse and his Westinghouse Electric Company in Pittsburgh recognized immediately what I had achieved, and within weeks they had licensed my patents and hired me as a consultant to help develop commercial applications for industry. 92,000 incandescent lamps, more than any installation in human history, illuminated the 1,000 893 World's Columbian Exposition in Chicago, using our alternating current system. That great World's Fair celebrated 400 years since Columbus, while visitors from around the globe walked through the White City, bathed in electric light, and understood that a new age had truly arrived. 2 years later, the Adams Power Station at Niagara Falls began operation using my designs, and Edward Dean Adams himself chaired the commission that selected my system over all competitors. Buffalo glowed with power, transmitted 26 miles through copper wire, thinner than your smallest finger by November of 1896, proving everything I had promised was not only possible but practical on a commercial scale. 60 cycles per second, the frequency I specified for that first great installation, still pulses through American power lines at this very moment. The number has not drifted or been revised because 60 remains optimal for motors and transformers just as I calculated in 1888. The great power grid has expanded and upgraded and interconnected across the continent, but the rhythm has never changed, and every lamp in America still flickers 60 times per second, too fast for human eyes to perceive, at the exact frequency I determined was ideal. Intelligent men resisted this revolution fiercely, and I must address why they fought so hard against the obvious future. Edison waged what historians now call the War of Currents, a campaign to discredit alternating current as inherently lethal to anyone who touched it. He sponsored public demonstrations where animals were electrocuted with alternating current to prove its dangers, and he promoted alternating current for the newly invented electric chair, hoping the public would associate my system with death and execution. His concerns about high voltage were not entirely manufactured, and the first electrocution deaths in the electrical industry did come from alternating current equipment. High voltage is genuinely dangerous in untrained hands, and I wagered that the superior efficiency of my system was worth the additional risk it carried. History validated that wager, but it was a wager nonetheless, and Edison's caution arose from genuine observation rather than mere commercial panic at losing his monopoly. Edison's method was inefficient in the extreme, and I once described it publicly in terms he did not appreciate. If he had a needle to find in a haystack, he would not stop to reason where it was most likely to be hidden. He would proceed at once with the feverish diligence of a bee, examining straw after straw until he found the object of his search through sheer exhaustion of possibilities. A little theory and calculation would have saved him 90% of his labor and years of wasted effort. This criticism does not diminish him, because our first meeting filled me with amazement at all he had accomplished without formal scientific training. Theoretical understanding reveals possibilities that empirical searching cannot find, though, and Edison was optimizing within the constraints of direct current, while I was asking whether those constraints were necessary at all. What this transformation means for the civilization you inhabit touches every aspect of modern existence that depends on electricity. The factories that manufacture your goods, the hospitals that preserve your lives, the transit systems that move you through cities all run on motors descended from the rotating magnetic field I visualized in Budapest, while the sun set and poetry filled my mind. Power reaches them through transformers, stepping voltage up and down across a grid spanning thousands of miles of wire and cable. Without alternating current and the transformer, every neighborhood would require its own generating station, burning fuel around the clock. Heavy industry would cluster around power plants like medieval towns huddled around castles for protection and resources. Electricity would remain a luxury for the urban wealthy, rather than a utility available to farms and villages across continents. Direct current is returning, and this may surprise you given everything I have explained about its limitations. Your mobile telephone charges on direct current from a small transformer in the wall. Solar panels generate direct current from sunlight striking their surfaces. Electric vehicles run on direct current stored in massive battery packs. Data centers are experimenting with direct current distribution for their servers to improve efficiency. The electrons in your computer flow in one direction rather than alternating waves, which means Edison may yet have the last word on something, not for transmission across great distances, but for the final journey from your wall outlet to your devices. The war never truly ended, but merely shifted battlegrounds to new technologies. Moving power from where nature provides it to where humanity needs it, across rivers and mountains and plains, from waterfall to city, from wind farm to factory, remains the domain of alternating current, and will remain so because my system works with the fundamental patterns of nature rather than fighting against them. Energy fills all of space, and the question I asked myself for years was whether this energy is static or kinetic. If static, our hopes would be in vain, and we could never harness it effectively. If kinetic, and we know it is kinetic for certain, then it is merely a question of time before men succeed in attaching their machinery to the very wheelwork of nature itself. Understanding the secrets of the universe requires thinking in terms of energy, frequency, and vibration, which is physics stated plainly, rather than mysticism wrapped in impressive words. Alternating current is energy vibrating at precise frequencies, and through understanding those vibrations I discovered how to carry power efficiently across any distance humanity might require for any purpose. The unit of magnetic field strength now bears my name, the Tesla, used in laboratories and engineering offices around the world. The Supreme Court of the United States ruled 50 years after my death that I held priority for the invention of radio over Guglielmo Marconi, settling a dispute that had raged for decades. More than 300 patents across multiple countries bear my name and describe my inventions. The achievement I value above all others is giving humanity a way to harness the forces of nature at their source and deliver that power wherever it is needed. Let the future tell the truth and evaluate each person according to their work and accomplishments rather than their publicity or their wealth. The present belonged to those who could not see beyond their investments in inferior systems, and the future, for which I have really worked all my life, is mine. Every time you turn on a light, you participate in that future I imagined and built. Every hospital ventilator, every electric train, every humming server pulses with the frequency I chose, following principles I discovered. Using machines descended from visions, I first drew with a stick in the sand of a Budapest park while reciting Goethe as the sun went down, and my friend watched in astonishment. Power transmission is not merely about alternating current surpassing direct current, because that understanding is too simple to capture the full truth. Nature moves in waves, in cycles, in rhythms of rise and fall at every scale, from atoms to galaxies. And working with nature means our systems must echo her patterns, rather than impose our own preferences upon the physics of the universe. The surgeon's hand holds steady while the lights stay constant and the patient breathes. 60 times each second, invisibly, the current reverses direction and flows again, wave after wave after wave, from the turning turbine to the healing machine. Everything I saw in my mind 140 years ago continues exactly as I envisioned it, and will continue long after every name is forgotten except the principles themselves, which are eternal.